All right, welcome here. We've got lesson two. We're talking about exponents and radicals. I do need to talk to you a little bit more about number. So in the last video about number, I helped you to get a feel for knowing your numbers. And so remember, algebra is based upon arithmetic. So have a good foundation for you in your number thinking. All right. So now we need to talk about radical types. So I'm going to try to use my little um, device right here. So this would be the got a little glare somewhere there. Okay. So this would be the square root sign. This would be a cubed root sign. This would be a fourth root sign. Okay. So those are basic signs there. They're all a type of radical. Now, what did I do with my eraser? Right here. Okay. Um, Now, for example, radical 4. Actually, what that means is what number squared gives you 4. That's what that's really saying. Let me just write this. Radical 5. Now, I could put a number out here and say 3 radical 5. I could put a expression out here, 2x radical 5. I could do that. I could take radical 5 and 3 radical 5. I could add them. I could subtract them. I could multiply them. I could divide them. Working with radicals. All right. Now the other part was rational exponents or exponents. So let me just take 1 second and do my official college algebra introduction. What is x squared times x cubed? Well, there's 2 x factors here and there's 3 x factors here, so that would be x to the 5th. Again, the shortcut is you're adding the 2 exponents. All right, so how about this? How about x squared cubed? Okay. Well, it's x squared times itself 3 times, so that's x to the 6th. That distinction must be as clear as the day is light. Okay, so keep that in mind. Now back to our radicals for a moment. All right, remember, the number inside here is called the radicand. This is the radical sign. You can also describe a radical, for example, radical 3, as 3 to the 1/2 power. This is called a radical. This is a base to a rational power. Rational power. So that's what you need to remember about that. Okay. Now, I urge you to, and I'll try not to overuse that word. Now, 1, we know that 1 squared is 1. 2 squared is 4. 3 squared is what? 9. Now, keep in mind, think about that chart that I showed you. 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 9 times 9, remember my shortcut, 81, and 10 is 100. Can you see that? Barely. There you go. Now, I believe it would be in your best interest to continue that chart all the way 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, all the way up to 20. Now you will use this left side more than these other numbers, but you will need to refer to them. So remember, that's x squared. What is that? That's 121, 144, that looks gross. 13 squared is 169, 14 squared is 196, 15 squared is 225, 16 squared is 256, 17 squared is 289, 18 and 19. This one is 324, and this one's 361. and 20 squared is 400. Let me take a second here and just check that out. 19 squared. We'll do this old school, okay? Did I say 361? 361. Okay. So please know those. Now, how do I use this? Okay. Well, let me just erase this section here for a moment. I'm going to ask you, what is the square root of 9? That all that's saying is go to the right side and look for 9 and look to the left. Oh, that is equivalent to 3. Try to remember, in order to know math well, try not to memorize everything and try to make connections. So I started with some basic arithmetic and I'm making connections with you. It is possible that your frustration in mathematics could be practically eliminated, but everybody's different and it depends upon how far you're willing to go. All right, so keep that little thought in mind. Now how about this? I want to know what 2 radical 25 is. Well, radical 25, what is radical 25? Oh, it's 5, so 2 times 5 is 10. Does that make sense? All right, now you're going to have to simplify radicals. Simplify radicals, so let me give you the most basic radical to simplify. Can you simplify radical 8? Well, what you're going to do, like doing a fraction, 2/4 is the same thing as 1/2 because 2 goes into both of them. You're going to follow a type of procedure working with numbers that helps you take apart a radical and simplify it. Now here's the way to do this. Which one of these numbers on the right goes into 8? Obviously one less than 8, so your choice is 4 would be good. So I'm going to rewrite that as radical 4 times radical 2 because 4 times 2 is 8. Now there is a little rule, you should have seen it, but I'm just going to hit it up here. Radical A times radical B is radical AB. Okay, so keep that in mind. But wait a minute, folks, what is radical 4? Radical 4 is equivalent to 2 radical 2. Does that make sense? Okay, that's how you do that. Now, so a little more difficult problem is, let's try radical, I don't know, 75. Oh, let's put a 3 over here. Well, first of all, I need a number on the right side that'll go in here. 75, no. Oh, 25 goes in there. So it's 3 times radical 25 times radical 3. Okay? But radical 25 is equivalent to 5. 3 times 5 times radical 3. 3 times 5 is 15. 15 radical 3. Okay? Now, I know it sounds kind of radical. Actually, it is radical because they are radicals, but you can do this. Okay? So please keep in mind that you need this chart from 1 to 20, and the 1 to 10 you are going to use a lot. Now, before we get out of here, now unlike some of the things we did in high school where we only did the things that everybody could get and all of that, but we weren't always ready for college. Have to be able to do other things. You have to be able to do harder things. So we're going to have to do the cubed. We're going to have to do the fourth. We're going to have to do the fifth. Okay? We could put the sixth here, but we're not. Now, obviously, if I put a 1 in all of these places here, cubed 4 to the 5th, 1 cubed is 1 times 1 times 1, which is 1. So I'm not going to use the 1. I'm going to go 2, 3, 4, 5. 2, 3, 4, 5. 2, 3, 4, 5. Here we go. Let's do the cubed. 2 cubed is 2 times 2 times 2. That is 8. This is 27. That is 64. And this 125. Okay, you need to know those. Now, does it continue? Yes, but let's just settle for 2, 3, 4, 5. This one's going to be 16. This is going to be 3 times that. It's another 3. So that's going to be 81. This is going to be 256. And this is going to be 625. Okay, it's another 5 of these. All right, then we're going to go to the 5th power. 2 to the 5th power is 32. 3 to the 5th power is 243. This is, I don't know, I forgot now. 4, that's 14, 10, 1024. Okay, sorry about that. And 5th is going to be 3125. Okay, now here's how we use this. I may say I want you to simplify this. The cubed root of 16. Oh no, how am I going to do that? Well, we are using this chart. So you're looking here on the right side for a number that goes into 16. It is 8. Right? 8 times 2 is 16. This radical type is cubed root, and this you know is equivalent to the number 2. So the simplified version is 2 cubed root of 2. Now that's the basics of working with radicals. There are a lot of other things that you need to know. That kind of hits some highlights. So Mr. Staples, what would be an example? Well, I don't know. I got a moment to spare here, so we'll just take a little deal like this. And how about we do a problem? 3 over radical 2. Okay, this is called rationalizing the denominator. You need to be able to get a radical out of the denominator. We're going to do that by multiplying by 1. Well, isn't 1 the same thing as radical 2 over radical 2? Why, yes, it is. So the top's going to be 3 radical 2, and the bottom's going to be radical 2 times radical 2. What is radical 2 times radical 2? Well, it's radical 4, which is 2, or it's radical 2 squared. Aren't I doing opposite operations, taking the 2, square root, then square? That's exactly right, so that's just 2. What's my answer? 3 radical 2 over 2. Okay, that would be one example. A lot of other examples. Because you understand the simple things, it means you can understand the more difficult things, but you're going to have to take a little time. And you can overdo it and you can underdo it regarding your time. I notice I have a moment here, so I'm going to do something very exciting here. I'll show you a little number trick while we're talking about numbers. That makes sense? So I will demonstrate a real quick 2 times 11. That answer is 352. Wow, that's pretty quick. Let's try that again. 251 times 11. That is 2761. How can that be? Well, actually, there's a little trick I'm using, and here's how it goes. When you multiply 11, copy your first number. Okay, see the 3? Then look, add the next 2 numbers together. That's a 5. And then copy the last number. See, I got that 352. Now notice how I did it over here with the bigger problem. So I copied the 2. I added these 2 together and got a 7. I added these 2 together and got a 6. And then I wrote the 1. All right, I know you're saying, Mr. Staples, is it really just that easy? Yeah, let's do a tougher one, okay? So you can impress your friends. 2, 3, 5, 7, 4, 1. I want to multiply that by 11. Okay, so how am I going to do this? I could do it old school, copy that, add. Take my first number. Add these 2 together. Add these 2 together. Add these 2 together. Oh, that's 12. So I'm going to put the 2 here, and I'm going to raise that 8, 1. Oh, that's 11. So I'm going to put the 1 here and put a 1 here. That would be a 3. And then 5, and then 1. Maybe you like that. Okay, I call that number fun. Best wishes. Keep up with what's going on, and we'll stay in touch. Bye-bye.